Hello, class. Welcome to the lecture on living in the Anthropocene, and we're going to unpack that word in a minute and talk about what that means. But let's get started. Yeah. So first question I want you to answer, and pause for a moment and respond to this question, but from a geological time scale, what's unique about this moment in Earth's history? All right. We're going to talk about that, and the subject of the Anthropocene gets to this very question about what is particularly unique about right now in Earth's history. And of course, the sneak peek answer is that the scale and scope of human influence on the planet is unprecedented throughout human history. A quick review from some stuff we covered in the previous lecture. Just a reminder on Earth system. So Earth system science looks at how all the different systems on the Earth function and interact together. So we talked about the atmosphere, the hydrosphere, the geosphere, and the biosphere being the four key Earth systems. And these things are all connected together. They function together. In order for life to exist on this planet, these different systems have to be functioning in the way that God designed them to. So our planet was created in order to have a seamless functioning between these different systems in order to create a balance, a way for life to exist and to flourish on this planet. So whenever there are significant changes to the water cycle, for example, that's the hydrosphere, that should get our attention because all of life depends upon a healthy, functioning, stable water cycle. Or whenever there are changes to the climate system, that's the atmosphere. That should really get our attention because that's one of the four fundamental Earth systems that life is balanced upon. And changes to the atmosphere as an Earth system are going to have repercussions for the other systems operating on the Earth. All of this is tied together, and that's the way that God built this planet and designed it to do. Similarly, within the biosphere, if portions of the biosphere are threatened, for example, by biodiversity loss, if you have large even insect losses or large losses of other species, these have repercussions to other life forms on the planet as well. There are no isolated effects. All of these effects trickle down and affect the rest of the system as a whole. Another, perhaps a simpler way to think of that are air, water, land, and life are the different Earth systems sort of boiled down into simpler, more everyday words. And the challenge that we see today is that these different systems are being impacted by humans on a really significant and unprecedented scale. So air, the amount of pollution that we're putting into the air, the ways that we're changing the atmosphere and the chemical makeup of the atmosphere are significant. The pollution that's going into the water, the other impacts upon the way the availability of fresh water, plastics in the ocean, changing the chemistry of the ocean, for example, the ways that we're changing the landscape, and affecting biodiversity in massive ways have significant repercussions for the rest of the planet as well. And that should be concerning to us. In fact, just recently, there's a couple of reports out that not only have they found plastic near the tallest point on Earth, near the summit of Mount Everest, but they've also found it in the very lowest point on Earth, the bottom of the Mariana Trench in the Pacific Ocean. So there literally is plastic, human-made plastic, that has touched every inch of the Earth's planet. Now, if you look at the historical scope of what throughout the Earth's geological history. So again, this is assuming a long time scale of Earth history. If you look at that, and these are not evenly broken out or spaced apart, as you will see here, but there's a variety of different eras. Geologists point to a variety of different eras throughout Earth's history. Of course, we're all familiar with things like the Jurassic era because of great movies and because what's more fascinating than dinosaurs, really. But one thing worth noting here, so the Holocene era is the only period during which humans have thrived on this planet. The Holocene era is only a span of about 10,000 years. So it's important to note that throughout the history of the Earth, the period that humans have played a significant role is only a really small portion of that overall history. So that's, I think, helpful context when looking at this overall scheme of things. But the era of human dominance is a relatively short period of time. And that's because we live in a really unique time of ideal conditions on the planet right now. Again, looking at a several 100,000-year time scale, one thing that often is lost when we think about the ice ages, I think growing up, many of us think of the ice ages as the ice age is the aberration, right? Or if you know a little bit more about Earth history, you know that there's been a cycle of multiple ice ages. We think of those as the aberration. Actually, the warm periods between the ice ages are the aberration. The ice ages are more the norm. So if you look at this cycle here, this looks at temperature change compared to present day temperatures over the past 450,000 years. You see that there's a cycle about every 100, 120,000 years. There's a cycle where the Earth suddenly gets much warmer, more like temperatures they are now, maybe a little bit above. And then begins a long, slow period of cooling for a long ice age, and then warmer, and then cooler, and warmer, and cooler. The reason for this, it gets into this whole astronomical thing called the Milankovitch cycles, which has to do with small variations in the Earth's orbit around the sun, which is beyond the scope of what we're talking about here. But the point being that right now we live in a really ideal time. Our nice warm temperatures that we experience out, nobody wants to live in the ice age. The ice age is not super pleasant. We live in this nice ideal period of time that has lasted for about 10,000 years. And that's been really ideal for civilization to thrive and to flourish on this planet, which is why that we have seen that take place. Now, most of human history, we've impacted the environment. We live in it after all. It's natural that we're going to have impacts on it, but our impacts have only been on a local level. Now, this is a bit of a longer quote taken from a textbook that I used to use for this course called Humans in the Landscape. Sorry, I forgot to put the citation here. It says, I'm not going to read the whole thing, but prior to the widespread use of fossil fuels, the energy harvest available to humankind was tightly constrained. So for most of human history, we had a really constrained amount of energy available to us. So a little bit of water and wind for places that had that and knew how to harness the technology, but not on the scale that we have now. We didn't have massive concrete dams like we do now. We didn't have huge wind turbines that were hundreds of feet tall. They were very small. Our technology was somewhat limited. And we were also, we had most of the rest of energy, and most of the energy in the world come from muscular energy, human or animal muscular energy. Now, all of that comes from eating other animals and ultimately from eating plants. And we're limited by suitable land being available, shortage of water in many places, and the inescapable biological inefficiencies of muscular energy. So muscular energy, we'll talk about this more when we talk about agriculture, is very inefficient because, first of all, plants only take in a small percentage, what does it say here, 1% of the solar energy that falls on the earth. So they only capture a small percentage of that, plants do. And only a small percentage, about 1/10 of that energy that's captured, gets stored into plants and then transferred into usable energy as well. So a lot of that is lost to metabolism processes. Same thing as you go up the food chain, and humans are high up the food chain. When you go up the food chain, a lot of the energy that is the initial energy that comes is lost as you move up the food chain in order to metabolize, in order to grow the organism. So it's a very inefficient process. All of this amounted to a bottleneck upon human numbers, the global economy, and the ability of humankind to shape the rest of the biosphere and the world around us. So this bottleneck for most of human history, our lack of access to adequate energy has bottlenecked our ability to grow as a species and to influence the planet. This natural bottleneck, which resulted in primarily relying upon, like we said, muscular energy, human and animals doing the work, that's been what has prevented us from growing and expanding. So question 2 for you. Take a moment and write your thoughts on this down. But how did this energy bottleneck limit humanity pre-1800s? So what were the limitations? What were the things that, the challenges that we faced because of this bottleneck? What are the ways that it constrained us in our ability to advance as a society? Okay, hopefully you thought of a few there. Several pre-industrial limitations that I would regard as short lifespans. The average lifespan before the Industrial Revolution was about 35 years old. I'm already quite a bit past that. So short lifespans, significant inequalities around the world. Obviously no electricity, no things like refrigeration. The convenience of being able to heat our homes with the flip of a switch was not there. Limited trade, so you're limited to what you can harvest around you. If you live in a cold climate, you better be planning out for winter. You better be storing up because there's not going to be supermarkets you can go to where they flew food in from around the other side of the world. Very limited population. There were very high death rates. We didn't have modern medicine. So with high death rates, it really constrained population growth significantly. No modern conveniences, no long distance transportation, and the work was really hard. Humanity had to work really hard to get anything accomplished. So for most of human history, there were significant constraints. These are what a lot of them looked like. Life was challenging, life was difficult, but there are a lot of limitations to what humans could do and accomplish. Now, all of that changed in a significant way with the dawn of the Industrial Revolution. So starting in the 19th century, with our ability to figure out how to harness the energy in coal. So fossil energy that in the form of coal, oil, natural gas, stored up as hydrocarbons in the ground. We figured out how we can burn coal to create energy, how we can mine and burn coal to create large amounts of energy. This was fundamental to advancing human society in many different ways. You can't understate the importance of the Industrial Revolution for advancing society in a whole lot of different ways that really benefited humanity as well. Opened up massive new energy sources. So if before you're limited by muscular energy, what you could harness with chopping down trees to burn, hauling those trees using animal labor. Well, now, thanks to coal and thanks to things like the steam engine, we're able to harness this energy much more efficiently and to burn it in order to create a lot more benefits for human society. So Industrial Revolution fundamentally changed how humanity interacted with the earth. And what it did is it busted open that bottleneck because all of the limitations that were previously there were no longer a barrier to growing humanity. So these were the limitations that were here before. Industrial Revolution brought us to this incredible new resource of fossil energy stored in the form of fossil fuels buried underground that we figured out how to harness that energy, how to burn it and utilize it for the benefit of human society was really important. Now, as you could guess, of course, when you look at a history of global energy consumption, you go back to sort of before the Industrial Revolution began, and you see, if you extended this out farther, it would look pretty much the same. You have more or less a flat line of a certain amount of energy we use. Again, that's the bottleneck right here. Bottleneck was preventing us from increasing beyond this because we didn't have the capacity to expand our energy growth. We were limited in all the ways that we've already talked about. Now, as the Industrial Revolution began to take off, you see a greatly increasing amount of coal. This gray is coal, here oil being blue, gas being purple. So you see a pretty tremendous growth here between 1850 and 1950. You see a tripling of energy from about 7,800, I think it is, terawatt hours to 28,000 terawatt hours. So significant growth in energy use over that century. That was really key. And that was really what it looked like as the world began to expand our use of this energy resource. With this energy explosion comes economic growth, more exploitation of natural resources, as you can imagine. Because we have access to more energy, we can now use that energy to further access more energy and to increase our ability to continue to harvest these natural resources and to use them, which is why you see this really significant increase in the types of ways that humanity is engaged in resource extraction and growing and expanding. That bottleneck is busted open, and we are now pouring out and expanding in a lot of different ways. Now, around 1950, you see an even more exponential growth. So if you thought growth was significant from 1850 to 1950, look what happens after 1950. You see what's now a six-fold increase from 1950 to today, all the way up to 173,000 terawatt hours today of energy use. Huge gains, massive amounts of gains, continuing with fossil fuels as well, and then beginning more recently developing into more resources, nuclear energy and other renewable energies on a larger scale as well. So we see this significant expansion But let me ask you this question. What do you think changed around 1950? What change happened? This doesn't happen on accident right here. This shift from increase to really dramatic increase happens for a reason. So what do you think? Write down a few ideas. So a variety of different factors play into this dramatic increase that we see, but in large part, a lot of it has to do with the post-World War II growth economy. So the world economy ramped up in order to fight World War II. The scale of that war encompassed necessitated a dramatic increase of industrial production and mechanization in a significant way. Now, once the war was done, we had all of the resources invested into those factories. We had new technologies like plastics and a significant assembly line technology in all kinds of different industry. So what are we going to do with that if we're not making tanks and bombs anymore? Well, that's going to shift to make other things like cars and other products for human society. So we have a massive growth in the economy. We have advancements of new technology that are out there, beginning of computing power not long after this. We also have a growing middle class in many places around the world. For the first time, you have not just the masses being poor with a few people being wealthier. You have a growing middle class that is beginning to want more items, to be able to purchase more things, to use that purchasing power to buy goods. And we have new energy resources. We have nuclear energy coming online. We have natural gas becoming a much bigger part of the economy, and the oil boom as well, as particularly as Arab oil countries are beginning to really tap into that. And we're beginning to build our infrastructure around that, the automobile, other forms of transportation. So this period is often referred to as the Great Acceleration. During the Great Acceleration is the time that we saw these energy expenditures, growth in the economy, advancements of new technology really take off and grow exponentially following the World War II period. And we see this in a lot of different variables as well, whether you're looking at population or water use, transportation, GDP, energy use, fertilizer consumption, all of these different things show the same thing. You see exponential increases. These dotted lines here are the 1950 marks. So look what happens from 1950 on for these different ones. You see exponential increases in that. In other words, the world is growing and advancing. That bottleneck has been completely removed. There's nothing in the way of preventing significant human population growth, significant economic expansion, significant growth of trade, rolling out of new technologies. All of these things are increasing at a very rapid rate. Now, toss in some new modern agriculture, and we'll talk about what that looks like later on, and growing economy. So you've got this huge amounts of new energy resources that, as you would predict, growing the economy in significant ways. Agriculture is expanding, so huge growth going on. This is the Great Acceleration. But here's the question for you. Take a minute and jot down some thoughts here. What benefits did this transformation bring to society? So remember to pause it, write down some answers. All right. So benefits, hopefully these are fairly obvious. Electricity, modern medicine, transportation, airline travel is very significant. Convenient heating, mechanization of things. Think of how would we be able to feed a growing population if we didn't have mechanization of agriculture? New goods and services, new job opportunities, emerging middle class, mass-produced agriculture, all of these things that we really love about society and we want to keep. Tremendous benefits. So we should all pause and be really grateful for what this fossil energy has provided for humanity over the last 70 or so years and longer, really, going back to the Industrial Revolution. This has really transformed society in enormously important ways. But here's the trick. And pause the video here and write down some of your thoughts. What problems did this transformation bring? Because it's not without its consequences, right? Okay, so as you can guess, yes, Tons of benefits. We're so grateful for the Industrial Revolution, so grateful for fossil fuels. But they've also caused a lot of problems that we're now beginning to really grasp are quite serious in how they're impacting humanity. Changing global climate system, one of those 4 Earth systems, the atmosphere. We're fundamentally changing the chemistry of the atmosphere. We'll talk about that later on and what that looks like and how we know that that's the case. Changing the chemistry of the atmosphere around us. Widespread pollution in really massive ways. We don't notice it as much where we live, perhaps, but go to India, go to China. The pollution is really rampant there. In fact, the number one reason why people protest in China is not because they want democracy, it's because they want clean air. They're tired of breathing dirty air there, which is really widespread. Mass biodiversity loss, many human health impacts. We've done a lot, thanks to modern medicine, at addressing a lot of our health problems, but we are also beginning to cause really serious human health problems because of the pollution and consequences of the ways that we are expanding society. We're now seeing planetary scale threats. Talk about that in a couple of weeks. Declining natural resources. Some of these are inherently non-renewable, like all of these fossil fuels right here. In other words, sometimes we're going to run out of some of these things. And that's beginning to be a concern area as well. Ocean acidification, sea level rise, all of these things have really significant negative impacts on human society. This probably should have been in between those last 2 benefits and challenges, but just to look at some of the ways that society has transformed in these different ways. So we're seeing these things come up in a lot of different ways. This graph looks at carbon dioxide levels over the past 1,000 years on the planet. And you can see that for most of human history, at least over this past 1,000 years, but if you extend thousands of years beyond that, it still hovers around 280. This is measured in parts per million. This is the nice, safe, delightful level of carbon dioxide in the atmosphere. 280 parts per million is perfect. Keeps the world just right in the way God designed it. And we're grateful for that. As you can see, starting with the Industrial Revolution, this begins to inch up. And when we talk about climate change, we'll explain why. The simple bit of it is when you burn things like coal, that releases carbon dioxide into the atmosphere. You burn coal, carbon dioxide comes off. Carbon dioxide, we know, traps heat. And we also know it stays in the atmosphere for over 100 years. So as you can imagine, that's what's leading to warming of the planet. So we saw up to 1950, we saw pretty noticeable increase here. There's a real trend going on. Well, it's been even more bothersome since then, as that increase has only gotten steeper with the exponential increase to the point where now we're almost about to 420 parts per million, up from the safe level of 280 parts per million. So very significantly increased. When did we realize what we were doing? That's a good question. We'll get to that in our climate talk, at least related to this graph. But you can look at this at a whole lot of other factors as well. The short of it is that growth puts enormous pressure on the environment. Growing human populations, growing resource consumption, growing consumerism, growing house size, all of these growing amounts of trade, all of this puts pressure on the environment because we're demanding more of the planet around us. And when we measure this in a lot of different ways, like you see here, you see that same exponential increase that we saw in the previous graphs. Whether you're looking at carbon dioxide levels or fish levels, ocean acidification, methane in the atmosphere, all of these different things, tropical forest loss, you see really significant increases in these as well. Because obviously, when we demand more of the world around us, that has impacts on the Earth systems that we live in. Living Planet Index is World Wildlife Fund report. Every couple of years, they measure what wildlife populations look like, and it's not looking good. 68% decline in wildlife since 1970. This is not super long ago. This is within the lifetimes of your parents, for example. So since 1970, 68% decline in wildlife populations around the world. Some subgroups are even worse than that. Freshwater species has seen an 84% decline. When you're talking about extinctions, they're now saying that we are seeing extinctions happen at about 1,000 times the natural rate. In other words, species go extinct naturally from time to time. It happens. But the rate of extinctions we are currently experiencing and observing are 1,000 times faster than the natural background rate because of human influence on habitat, particularly from habitat exploitation, overhunting, other things like pollution and climate change and invasive species have impact as well. But there's significant biodiversity loss, which has led many experts to say that we are entering another mass extinction. Similar to when the dinosaurs went extinct, we're experiencing one right now, and they're called the sixth extinction, because if you look on that long geologic time scale, the 5 others, that this is the sixth extinction. And what's unique about this one is that it's not caused by an asteroid. This one is specifically caused by the actions of one species on the planet, Homo sapiens, that our actions are the cause of the mass extinction that's going on around the world right now. And we see all kinds of other ridiculous things happening as well, like rainfall falling on the summit of Greenland, which has never happened before, or the Great Barrier Reef, which has lost about half of all of the reef has become permanently bleached from coral bleaching. The worst wildfire seasons, it seems like every other year California is beating its own records for the worst wildfires that we've had. Amazon as well as lots of problems as well. So significant challenges around the world. In other words, the world is in bad shape right now. Sorry, this is a bit of a downer one. There's good news, there's solutions, there's things we can do. This lecture really kind of paints the scope of the problem that we're facing in order, because if we don't appreciate the gravity of the problem, we can't actually respond in an appropriate and helpful way around us. So all of this has led some geologists, and geologists still debate on whether we are in the Anthropocene or not. If you remember, looking back, historically, we've labeled the Holocene as the era of humans. The last 10,000 years from a geologic time scale has been called the Holocene. Many are now saying we are out of the Holocene. In other words, it's not just defined by steady temperatures and the rise of humans, right? We're now in a new era called the Anthropocene that's defined by humans fundamentally altering Earth's systems and chemical processes on the planet. So we're not just the dominant species, but we have fundamentally changed the rest of the planet in a way that if aliens were to land here 10,000 years from now, or 100,000 years from now, the evidence of humans, even if we were long extinct, they would still be able to see the evidence of human impacts on the planet at that point. So very significant. So are we in the Anthropocene? Here's, I think, a helpful way to think about that. So the difference between how humans lived, say, prehistorically and about 200 years ago, how big of a gap is that compared to how humans lived 200 years ago to today? And where is the gap biggest? Is it the biggest between today and 1800, or 1800 and 2000 BC, or beyond, right? So my suggestion, I'm not a geologist, I'm not an expert in geological epochs. I would suggest that probably this gap here over the past 200 years is bigger. The difference in lifestyles between these two it seems to me more significant. Whether or not that means we're in the Anthropocene, I don't know. Certainly it means that the world is really different today. And it seems clear that humans have been a major reason that the world has changed. This is a picture of my father as a baby right here. So my grandparents, my father, he was born on June 25th, 1949. When he was born, the greenhouse gas concentration in the atmosphere was around 311 parts per million. Now, if you remember, 280 was the pre-industrial average. So it had risen from 280 to 311. Marked increase, but not really significant, not overly concerning, right? It seems clear that there's sort of an uptrend here. How that's going to play out, not entirely clear. This is my son, Ian. Ian was born June 22nd, 2009. Almost exactly 60 years. Is it 60? This is not Ian. That's embarrassing. This is my daughter, Katie. Ian was not born 2009. What am I thinking? Oh yeah, this is Katie. This is my first child, Katie, who was born June 22nd, 2009. Almost exactly 60 years after my dad, her grandfather. When she was born, CO2 concentrations were 389 parts per million. Look at this increase in just 2 generations. So within my lifespan, so going from my father to my daughter, we've gone from, it looks like it's starting to go up to, holy crap, we have a problem on our hands. And she's not even a teenager. She turns a teenager in a few weeks. She's not even a teenager yet. And we've already gone up another 30 parts per million beyond this. So there's something out of control. And it relates to what we're doing to the planet. So let's look back at this graph again, right here. This is what we want. We want these benefits. These benefits are not negotiable. These benefits are not up for debate. These are things that are fundamental to human society, and we need more of them. There are many places in the world that don't have electricity yet. Modern medicine is pretty widespread, but there's still some health related things that we need to work on. Transportation and heating, more jobs. We need growing economies to address poverty around the world. We need more of these benefits. But we can't do it if it makes these problems worse. So we have to find a way to do that. So here's my shorthand for what this can look like. We don't want this. Our goal isn't to use oil, right? Or coal or whatever. This isn't our goal is to get these benefits. And if there's a way we can do it without the problems, then gosh darn it, we should do that. And it turns out there is. Clean energy wins. This is way oversimplifying. I apologize for that. We will get into the complexities of this a lot in this class. So we'll explore the complexities. But this is it. This is the fundamental question of our time. Just like I said, the importance of the Industrial Revolution can't be overstated. The importance of this graph right here can't be overstated. This fundamentally is the challenge of the 21st century. How do we continue and even expand these benefits while avoiding and reversing the problems that we've already begun to cause? And it's way more complex than this, but the foundation of that revolves around changing our energy sources to more clean energy sources, growing our economies in a sustainable way, and focusing on sustainable agriculture. This is the key to how we do this. Now, it's really complicated. All of this transition is complicated. And there's a lot that plays into that. But fundamentally, this is what we have to look towards. This is what we're moving towards as a society. If you're rolling your eyes because you think I'm oversimplifying it, I agree. It is not that simple, but we're going to unpack what that looks like. And I want you to get excited about this idea, because I think when you put an idea down on paper like this, when you look at this, you say, oh, that makes sense. Fossil fuels aren't so much the bad guy. They brought us some benefits, but we found out they have problems. How do we keep those benefits without bringing the problems with them? That's the question. That's the key. So what next? Last question I want you to reflect on. Is it possible to correct our balance problem? What are some of the challenges there? You don't need to write an essay. You don't even need to write a paragraph. Just put a 1-sentence answer down. What are your thoughts? Can we do it? What are some of the challenges that we can do to get there? These will be the kinds of things that we'll explore in this class. All right, thanks.